What's up, AP Calc students? Today we're doing 4.1 part 2. We're still doing the chain rule. We're just going to do some more complex chain rule stuff and then get into parametrics. Yeah, I just wanted to split this up so you could feel comfortable with the basics of chain rule so we could apply this new stuff today. All right, for this example, it says find derivative with respect to y, with respect to x of y, if y equals tangent 5 minus sine 2t, or x. That should be an x. All right. So we're going to do derivative with respect to y is going to be equal to, now follow me, this is an outside, right? And this is the inside, so we're going to do derivative of tangent is secant squared. The inside is going to stay the same. Right, now we're going to do the derivative of the inside. Oh, I wrote that wrong. Minus sine 2x. There we go. Okay, so now we're going to do the derivative of the inside. So the 5 is gone, right? 5 derives out. Then we have negative cosine 2x. Now notice that this 2x is inside, so that's another derivative that we have to do the, that's another piece that we need to do the derivative of. So the derivative of 2x is 2. So what we really had here was like 3 compositions, right? So we had to unfold 3 layers. We did derivative outside, inside the same. Then we derived the inside, but the inside, this 2x, technically when we have sine 2x or cosine 2x, that's in parentheses. So that's another inside function, which we had to account for at the very end. So be very careful when you're doing chain rule. And we can have multiple insides inside of our function, but it's not too bad. Just be aware of it. And just keep going along. So this whole thing, I guess, if we wrote it in simplest form, I guess that's kind of as simple as it get. I mean, we could move the 2 in front, but it's not going to change much. All right, so this will be it. We should do another example since we have some time. So let's do one from the book. Let's do square root tangent 5x. Okay, so we have square root tangent 5x. Alright, I like this one because we have the root. So remember, we can rewrite this radical as a rational exponent. Right, so that would be, well, it's to the first power, and the root is 2 because it's square root. Now also notice that anytime we have a trig function, and it's got something tangent like 5x or 2x or 2t or whatever, that's technically in parentheses, so that we have to treat as another inside. So let's work our way through this. The first step is we're going to do our power rule on this outside function here. So we're going to drop down 1/2. The inside stays the same. And then we're going to subtract 1 from the 1/2, which is negative 1/2. We're going to do the derivative of the inside here, which is secant squared 5x. But then we have this other inside here, so we got to do the derivative of that, which is 5. And technically you can leave it like this. If you don't want to leave it like that, then we can do secant squared, well, we can do 5 secant squared 5x, right? Just rearranging the stuff here. Over, right? This negative sign means that we're going to do we're going to do the reciprocal, so this is going to be square root tangent 5x in the bottom. And I guess technically 1/2 of that, 1 times 5 is 5, but then we could put the 2 in the denominator with the square root. Okay? So either way is fine. Alright, now onto parametric stuff. So this parametric stuff, dy dx, is equal to dy dt over dx dt. And this applies when we have a parametric equation, meaning that the x and the y are defined by two different functions. So it's pretty easy. All we have to do is take our function, and then we're going to divide the derivative of the y by the derivative of the x with respect to t. Okay, so the derivative of x with respect to t would be derivative of secant is secant tangent. Secant tangent. Yeah. Secant t tangent t, and then dy dx is going to be secant squared t. Alright, so we're going to do y over x, so we have secant squared t over secant t tangent t. Now we might as well go over it, I guess. So whenever we have secant squared t, what that means is we have secant t times secant t. Or secant t squared. So this notation is the same as that notation. It's just that they don't write it like this form usually. But when you're in calculus, sometimes we want to write it in that form because it's easier for us to chain rule or whatever we need to do to it. Or in this case, we can cancel our secants, right? So now let's rewrite this as sines and cosines. So that would be 1 over cosine t times, actually, let's just do tangent is sine t over cosine t. Now we have a complex fraction, so what we're going to do is take this, take our numerator, right? We talked about this in Algebra 2 and in pre-calculus. So anytime we have a complex fraction, we can change the division to multiply by the reciprocal of the denominator, right? So we're going to flip that, cosine t over sine t. These cancel, so we have 1 over sine t, which is cosecant t. Alright, not too tricky. It's just that you gotta do the derivatives of two things and then simplify a little bit using your algebra and your trig stuff. Alright, so that's it for our chain rule. Hopefully you guys had enough practice or get enough practice that you're comfortable with it and you can use it in any situation where it comes up. Good job.